Hi, folks, and welcome to App Service Networking Options Learn Live series. My name is Orestis Meikopoulos, and I'm a service engineer. I'm part of the App Dev Fast Track for Azure team of the Azure CXP engineering organization. And in Fast Track, we enable the effective design and deployment of Azure solutions in the cloud, and we also guide our customers to correctly start and confidently continue their Azure journey. I have here with me my colleague Arthi. Arthi, would you like to introduce yourself?
Thanks, Orestes. I'm also an engineer on the Fast Track team, Fast Track for Azure team, and I work closely with the Fast Track for Azure App Dev team. We help with PaaS deployments and PaaS networking guidance for the customers. I'm very happy to share screen and present this topic, app service networking, the hot topic with Orestes, my teammate.
Great. We also have our moderator, Raul Alarcon, which will be moderating the chat and answer all your questions, so feel free to post them there. Say hello to our moderator. Hello, Raul.
Hi, Raul.
And this session is part of a Learn Live series on app service networking options. So you can go to the link that is currently shown in the slide, which is a collection that contains all learning content for properly understanding app service networking. It also contains the demo samples that we're going to show today, so feel free to check them out and run them yourselves on your own pace. In today's session, we will learn about the different ways you can secure Azure App Service from a networking perspective. The focus of the session will be Azure App Service, but you will also be able to apply a lot of the concepts we cover today to other Azure PaaS services as well, which is Platform as a Service. This is a two-part series, so today will be part one, in which we will see about Azure App Service out-of-the-box networking behavior and also the available security options we have here. We are also going to see how we can lock down inbound calls, both conceptually and in practice. We are going to see how to protect a web application using a web application firewall appliance. And also, we're going to see how to securely connect to a backend database in your Azure or on-prem network. In 2 days from now, there will be a part two, in which you will see how to lock down outbound calls, which are calls originating from your app service to other services, both conceptually and in practice. And we're also going to see about single tenancy and what is an app service environment in this case. First, what you need to know is that you can deploy applications in Azure App Service in multiple ways. By default, apps hosted in App Service are accessible directly through the internet and can reach only internet-hosted endpoints. Now, there are two main deployment types for Azure App Service. First of all, we have the multi-tenant public service, which hosts App Service plans in the free, shared, basic, standard, premium, premium V2, and premium V3 pricing SKUs. So what multi-tenant means is that there are different customers on the same infrastructure and maybe also compute. Now, for compute resources, they are also shared between different customers when you're in the free or the shared SKU plan. With basic or above, the compute is dedicated to you only. Regarding infrastructure now, your applications are always secured, but they share the network, address space, front ends, and some other components. We also have another deployment type, which is the single tenant or else app service environment, which hosts isolated SKU app service plans directly inside your own Azure Virtual Network. So in this case, both networking and compute infrastructure are dedicated to you only. Now, for many applications, you need to control the inbound and outbound network traffic. The features you use will depend on whether you are in the multi-tenant service or in an app service environment, in the single-tenant one. For today's session, we're mostly going to stick around the multi-tenant setup and the provided networking features we have there. And for that reason, we're going to have a demo setup and various demos we're going to see today. The demo setup that we have today provides some components. We have a base setup for a web application and a database. The web application, which is deployed as an app service in Azure, is communicating with the SQL DB using a managed identity. So what is a managed identity? That means that the app service, it doesn't need to maintain credentials like, for example, secrets or connection strings to be able to talk to the database. The credentials are managed by Azure in this case. We also have a VNet with several subnets, with 3 different subnets. We have an application gateway installed in the application gateway subnet, and with a public IP address associated to it. And also it has a backend pool for the web app. So that means that through the public IP and the traffic will go to the application gateway, and the application gateway will be able to reach our app service. Also, we have an Azure front door service with a backend pool for the web app, for the same web app. So that means that we can also reach our app service through Azure front door. We also have 2 other subnets. We have the integration subnets, which will be used for the outgoing traffic. So in the second session, of this series, in 2 days from now, we're going to use that. And we also have a private link subnet, which we are going to use to create our private endpoints for our app service, and we're going to see demos of that later. So, Arthi, regarding this demo setup, we see those types of scenarios a lot at customers, right?
Exactly. Yeah, we see like three main scenarios here. One, like directly accessing the web application, the app service using the app service hostname, and the other one is like accessing the application, the web application through front door using the front door hostname. And the third one is like accessing the app service, like using an application gateway, which is also a very common scenario. We'll cover that in the demo setup overview demo.
Nice, nice. Thank you. And Arthi, as you will be doing the demos for today, can you maybe show us the deployed application we have for today and the 3 different ways we have configured to access it?
Sure, definitely. Thanks, Orestes. Thanks for the overview. It was great. Yeah, let me start sharing my screen so we can look into the resources for us. Basically, this is the App Service Networking demo resource group that I have created.
Arthi,
And
a bit?
yeah,
Can you zoom for a bit just to
sure,
see? Okay.
sure. Yeah. Hope this is much
Yes.
better.
Thank you.
Yeah. So we have the App Service Networking demo application gateway that Orestes showed us. And we have the App Service Networking demo, the public IP that we saw, like it's attached to the application gateway. And we see the virtual network that contains the application gateway on all other subnets. And we see like the front door and CDN profile here, which is also the one that we saw in the whiteboarding that Orestes showed us. And we see the SQL server, and we also have an app service plan that hosts the app service, and we see the app service here. And here is the backend database, which is the sample DB that also gets deployed from this resource group and from this deployment. Basically, this is the actual repo that we used for deploying all the resources in the resource group, and we'll be sharing that in the chat as well for us. This is the great one to play around with. Like we have a lot of stuffs here, and we can play around and learn more about app services from there. So let's go over the 3 common scenarios that we discussed. So let me start showing the app service directly accessing the app service using its hostname. Yeah, it get loaded. So I'm gonna use the browse button to open it in one another tab. So here we see that there is Inspector Gadget application that was deployed on the app service. This is a great application to actually play around with and also do a lot of stuffs like generating requests and also using the managed identity. We can connect to the backend database as Orestes showed us in the whiteboarding. And we will also see that like how to actually generate a request and connect to the backend database using the managed identity. As we are in the app service, directly accessing the app service, I'm going to show next like how to connect to the backend database. Here, I'm going to click on the SQL tab, And if I click on the submit button, it will generate a request. Before that, I want to cover like SQL connection string that we see here. As we see here, we don't see any user credentials here. We don't have any usernames, any passwords that we need to manage. We are using the managed identity, which makes it so simple, like it is managed by Azure. So we don't have to remember any credentials, username, or anything of that sort. So we have the managed identity that being used. So I'm going to generate a request by clicking on submit. Let's see what it returns for us. So it
Can you
returned the yeah,
can you zoom in a bit?
yeah, sure. Let me zoom in. Okay.
Okay, that's fine.
Sure.
Thank you.
So this is the, thanks Orestes. So this is the access token here that was returned as I generated the request. And we see the output that shows like the user with the username, this one, app service networking demo, and the app service name probably is logged in from this IP address. And this IP address we will cover like from where this IP address comes from in the upcoming demo that we will see. For the outbound IP addresses and all. And this will be like one of the outbound IP addresses on the app services that was showing up here. And we see it's connected to the sample DB, which is the backend database. And the backend database, we see that it is connected on server and server with this name, which is the SQL server. So we see so many details here as we generated the request. And let's also quickly see the other common scenarios like accessing the app service through the front door and also through the app gateway. Let's see how to use it through the front door. So through
So
the
before
front
we
door,
access the app service, right? Before we access the app service directly. And now we're going to see
exactly.
access through the front door and also through the application gateway, the other two ways we have, right?
Exactly. Yeah, we are going to do that. So I'm going to grab the front door hostname for us, and I'm going to open it up in the browser. So as I open it up, I'm hoping that we should see the app service here deployed behind the front door. Yeah, so that's what we get. We see the inspector gadget web app, which is deployed behind the front door. We see that front door scenario. With that, we can access it using the front door hostname. So let's also see the other one where we can access the application gateway public IP in a browser, and we can open the web app behind that. So I'm going to grab the public IP here and I'm going to open it in our browser. So it's going to load the web app with this public IP. Yeah, so we see the Inspector Gadget web app here that gets loaded as we opened it through the application gateway's public IP. So these are the three common scenarios: directly accessing the web app through its hostname, app service hostname that has Azure Websites.net. And the second one is like using Azure FD.net, which is the front door hostname. And the third one is App Gateway, which is using the App Gateway's public IP. Over to
Nice.
Orestes.
Nice. Thanks a lot, Arthi, for the demo.
Thank you.
And let's start discussing about App Service default networking behavior. First of all, Azure App Service is a distributed system. So the roles that handle incoming HTTP or HTTPS requests are called front ends, and these are the front ends here. Now, the roles that host the customer workload are called workers, and these are the workers here. Sorry. In the case of a multi-tenant setup, all the roles in an app service deployment exist inside a multi-tenant network, which is shared by many different customers, as we said in the beginning. Because of this, you can't connect the app service network directly to your own virtual network. Out of the box, app service now makes use of a shared incoming IP address for all customers. So in this case, this IP address is shared for all customers. From this incoming IP address, the call is then routed to front-end nodes that act as a load balancer here, in this case. Now, these front-end nodes will actually forward the incoming request to worker nodes specific for each customer, and this is based on the incoming domain name using a process called host name balancing. So this is host name balancing here happening. Let's see an example here. Let's say, for example, that we have several applications named App A, App B, and App C, and they are deployed to the worker nodes of the app service plans you see in this slide. So App A is here, App B is here, and App C is here. So the first app service plan on the top here belongs to customer A, and App A is deployed in this app service plan. App B is deployed to the second app service plan, which belongs to customer B in this case, and App C is deployed to the third app service plan, which belongs to customer C. Now, let me quickly change the laser here to do a highlight and change my in color. Okay. So in the first case, let's say that a user tries to navigate to appa.azurewebsites.net in this case here. Then what happens is that this traffic will first hit the shared incoming IP address here. Then it is routed to the front-end nodes that act as a load balancer. And these front-end nodes will actually forward the incoming request to the first app service plan here, which belongs to customer A and where app A is actually running. Now, let me quickly change my in color here. And the same applies for the traffic that destined for app.b.azurewebsites.net, which in this case will come here, will reach the front-end nodes, and the front-end nodes will forward this traffic to customer B and app B here in this app service plan. And the same will actually be done for the third case as well, the appc.azurewebsites.net, where this traffic will reach this IP here. Then it will be routed to those front-end nodes that act as a load balancer, as we said, and those front-end nodes will actually route the traffic to app C here. This is called host name balancing. Now, for outgoing calls, which means calls originating from your app service instance to any other services, the internal IP address from your worker nodes here will get translated with a process called NATing to a list of shared outgoing IP addresses. So these IPs are also shared. This means that these outgoing IP addresses are not safe to use in case you want to lock down traffic to, for example, a backend database or to another web API, for example, to only your app service worker instances. In a later demo, Arthi will show us how to lock down the incoming traffic to our app service. For the outgoing traffic, for the outgoing part, this part here, stay tuned for the second part of this series 2 days from now. Before actually going to the demo, some things to note here, to highlight here. So incoming calls, once again, are routed over shared infrastructure. So this infrastructure here is shared between different customers in the multi-tenant setup. Also, outgoing calls, meaning calls from your app service to other services, are also routed over shared infrastructure, like this one here. So that means that internal IP from your worker nodes will be NATed to a shared outgoing IP address. And finally, you own the app service plan infrastructure if you are on anything above the basic tier. So if you are on basic tier or above, you get to own this app service plan, like in this case. Customer A, for example, owns this app service plan, customer B owns this app service plan, and customer C owns this app service plan. Now, in the next demo, we're going to see all these out-of-the-box networking settings for our app service. Arthi, back to you.
Sure. Yeah. Thanks, Orestes, for the concepts there. Let me start sharing my screen. Yeah. So we see the screen now. I'm on the networking page. So this is the networking page where we actually see the same whiteboarding that we saw over there, where we saw the inbound related features like inbound traffic related features, and we see the inbound address, inbound public IP address here. So this one, like Orestes mentioned, it's a shared one. It's going to be load balanced based on the customer's host name. and that part is called as hostname load balancing. The hostname load balancing we see over here. So in the middle part, as it is pictorially represented in the Azure portal, similar to the whiteboarding, we see like inbound is placed to the left, and in the middle we see the app service networking domain, the host name of the app service, and we see the outbound related features and those outbound addresses, and even the outbound addresses or shared IP addresses. Let me open it up like a little bit. So we see a lot of outbound IP addresses here. So these are the shared outbound IP addresses that will get NATed to the worker node IP address, and from there to the other Azure services that it's going to access. So we see all those details here. Now let me go to the SQL connection. So here I wanted to bring up this outbound IP address that we see here. So let me see if it's in the list of outbound IP addresses there. So let me go there to the portal. Yep, there was a blip. Good. So now I'm going to paste that copied outbound IP address from there. So we see that that's also in the list of the outbound IP addresses in the app service. So we can confirm that this is one of the outbound IP addresses on the app service that we see there in the SQL connection. So this call is like an outbound call from the app service to the backend database using the managed identity. So these are the major overview topics that I wanted to show. Like over to Orestes, he will share additional information
So,
about locking down the web application.
so the inbound address we saw earlier, I think it's like the incoming IP address which is shared between different customers that we saw in the diagram earlier, and also
Exactly.
the shared outgoing IP address that you showed is like the NATing process which happens from the which NATed the which changes the internal IP address of the worker nodes to a shared outgoing IP address which is shared between all customers in the multi-tenant setup. Okay, good to know, Arthur. Thanks a lot.
Yeah, sure.
Now, in the next walkthroughs, you will learn how to further lock down the inbound communication paths for your app service. Remember that Arthi showed us in the first demo that an end user could still go to the web app without using either the application gateway or the front door components. Let's start fixing that. Firstly, we're going to use what is called access restrictions. What access restrictions let you is that let you do is that they allow you to let you allow or deny access to your app service by filtering inbound requests based on certain IP addresses or address ranges. You can also deny or allow traffic based on HTTP headers, and this will be demoed later when we configure Azure Front Door. Now, the filtering action takes place on the front-end roles that are upstream from the worker roles where your apps are running. So the filtering action takes place here in the front-end nodes, and we can say something like, from this known IP, let this traffic pass, for example. So these front-end nodes are upstream from the worker roles, which are here, where your applications are running. And because the front-end roles are upstream from the workers, we can think of access restrictions as network level protection for your applications. Now, for example, I could say something like, for this known IP, allow, but for this unknown IP, please block this traffic here, and this traffic would never reach the app service. This feature allows you to build a list of allow and deny rules that are evaluated in priority order. It's like the network security group feature in Azure networking. Now, back to our demo. As a starter, let's imagine that a customer would like to lock down incoming calls to their app service, meaning they want to be able to control where the calls come from. So, Arthi, can you show us?
Sure. Yeah. Let me start sharing my screen. So I'm on the networking page now. So in order to configure the access restriction, in order to restrict the web application access only through certain services, like either through front door, or like we want to give access to only certain known IP ranges, we need this access restriction that we see here for the inbound traffic related feature, we need to go here and configure the access restriction rule. So basically, I will cover like two scenarios here. One is like blocking the access to the web app from my machine. Like I will grab my machine's IP address and I will try to configure a rule. That rule will actually block me from accessing the main site, the web app. So let me try like block my IP. This is uh, this is the name that we give. Basically, this can be anything that makes sense for us to identify that this is the rule. So since I'm going to block the machine IP, I'm going to choose the action as deny. And here, as Orestes mentioned, this is also similar to the priority where we configure in NSGs, the network security groups. So this priority, as low is the number, as high the priority will be. So if you want to give a greater priority to a rule, access restriction rule, our suggestion is like using a smaller number like this, 100, for better importance given to the priority rule. So this is an optional field, but I try to give the same information here as the name. So since it is like an IP range, I choose the type here as IPv4. And let me actually grab my machine IP from here. This is a tool that I use for grabbing my machine IP. So I have copied this machine IP. Let me go back to the screen and let me start adding that machine IP here. So once I added this, the rule is good. I have all the information out here. So let me start adding the rule. Once I add the rule, I have to click save. Otherwise, the rule doesn't get like saved to the web app. So that is where like I have to give that save option. Unless I do that, it will not be saved. So here it asks for like the Azure portal. It gives us that confirmation that if we really want to do the deny. So I give a confirmation that I want this rule to be in place. So as I confirm, it's getting updated to my web app. It just updated. So if I go back to the networking page again, I will see that the access restriction is now on. So it's turned on. We just saw that the rule is added. Let's also quickly see if that rule got saved here. So let me go back to this access restrictions page. This is the access in place. So this
I
rule
think did it
is
also
basically going to block me from accessing the web application.
did it also
Yeah.
change the default rule, I
So
think?
we see the rule. Exactly. Yeah. Once we added the rule, we actually see like there is a deny all rule, which is implicit, introduced by Azure Portal. So this means like the default action will be deny. And one more thing to note here is the unmatched rule action. The unmatched rule action determines if there is no match for an access restriction rule, then what action we want the web app to have in place. Like we want to allow the traffic or we want to deny the traffic. I'm giving like deny, but we can either switch it to allow if you want to allow the access to the web app.
So
So
basically,
that
if you
is
needed to
unmatched.
So basically, if you needed to only deny your own IP, then you would put unmatched rule action as allow, and then you would only have, with the priority 100, only block your IP address, as I understand.
Exactly. Yeah.
Okay.
If I choose to switch it to allow, then it's gonna block me and allow all other traffic to come through the web app. And there is
Okay.
also one more thing to note here, the allow public access. So this option, this is like recently introduced by Azure Portal. This gives a combination like we will cover one another scenario for locking down the inbound access, which is called private link. So we can have like both the private link in place and also the service endpoint in place. Like we can have public access and a combination of private access as well. That's covered in the private link. So basically the hybrid option is available because we can choose to have like public access as well for our site. So this is a new feature that Azure portal offers. So we saw that the rule is in place. Let's go ahead and test whether the rule is blocking us from accessing the web app. So let me try to open it up here. So power
I think
button as it loads, or I can use like from here. Sh-
okay,
Yeah. So
nice.
basically, what we are supposed to get is like we have to be blocked. So we are just seeing that our access to the application itself is being blocked. So the basic lockdown that we did is like going to block us from accessing the web app, especially me. So it's going to block me. So that we saw. Next, if there is any other option that we can access the web app in case we are getting blocked. Yes, Azure Portal offers one another option, one another console that we can use for accessing the web app. So let's see what is that console. We have like two methods for that, accessing the Kudu console or the SCM site that Azure portal offers in case we don't access the main site. So we can either go from here, but I will show like how to open it in a browser uh, ourselves. So I'm going to copy the host name. So now I'm going to open it in a browser. So when I open it in a browser, I need to make one single change that will actually launch the Kudu console site. I need to add like a .scm here in order to access the website's name and the app name. So once I click enter, and open it in a browser, I will see like it requires some SSO and it is like protected by some authorization that Azure offers. So basically, it's not publicly open to everyone. It's like open only to ourselves for accessing this Kudu console page. So this is very secure. And this Kudu console page is also very informative, like we saw in the Inspector Gadget web app. The same way like we can also play around with lots of features in the Kudu console as well. Like we can try to refresh, we can do like a bash, all the updates from here. So all these options are available if we try to uh, launch the Kudu console. So if I go back to the web app, I also wanted to show like if there is an option that we can use for blocking the Kudu console as well. So there is an option like in the access restrictions, we have an option to like create an access restriction rule for blocking this Kudu console page. So if I go to the networking page, in the networking page, so we see the access restriction here. I'll go here and I'll show like where we can configure the rule that can actually block the Kudu console page as well for us, like we did for the main site, right? Similarly, we can do that for the Kudu console also. So this is the main site access restrictions place. If I switch back to this tab, advanced tool site, it will allow me to configure rules for the Kudu console page, the SCM site. So I can either use like I can create a rule like we did for the main site for blocking the Kudu console page, or I can do like use main site rules. This is something to note. It keeps our work so simple. We can just use the access restrictions that is configured for the main site. The same one we can leverage for the Kudu console as well if we set this option, use main site rules to true. So if it, then it will automatically block me from accessing the SEM page as well. But I'm not going to do that for our demo. It's just for learning. So we just saw all these Kudu console page and like access restriction test, all that. There is one another scenario like we just used IP range or IP address that we are going to block using the access restriction. Now I'm going to show in our next scenario like how we can lock down the access through HTTP headers that gets used, and also I will show like how to lock down the inbound access to the web app completely, and it should be available only through the front door. So we will see that scenario in our next access restriction configuration. So I just
So you
removed the previous rule as we don't need that. Now I'm going to add the rule for us to access only through front door. So I'm going to do allow FD only on the name. Since the action is allow, I choose allow. And now I'm going to grab like the priority. I'm going to keep it as the same, the lower one, which is preferred. So I'm going to give the same description. Description is optional. Here, what I'm going to do is like I'm going to use the service tag option. What the service tag option gives us is like there is a specific IP ranges for each service that Azure generally gives for each of the service tag or the service. So this service IP ranges that generally is dynamic, and it is like it is constantly changing. So we can use like the service tag here for leveraging the IP ranges for that service itself. So that is why like we choose the service tag here. Since we are going to use front door, so we choose like Azure front door dot backend. So it's going to limit allow or it's going to like restrict access only to the front door profiles. Since front door is also like a multi-tenant and a shared service, we have to further limit down to our FD profile that we have created. For that, what we are going to do is like we are going to grab the front door ID and we are going to paste it. So let me go to the portal again. I'm going to duplicate. So what I'm going to do here is like I'm going to the front door. So I will collect the front door ID from there, and I will use it for using the access restriction rule for allowing access only to the front door.
Oh, I see. So you want to limit access
And
only to your specific front door, to our specific front door instance, and not to all the customers, because front door is a public is a
exactly,
multi-tenant. Okay.
shared service. Yeah, it's a shared service. So here we see the front door ID. I'm going to copy that. So it's copied. Now I'm going to paste it in the front door ID field here.
Okay,
So
makes
I
sense.
have everything in place. Yeah. So it's only going to allow our front door profile to access the web app. So it will not allow like all the front door profiles to access the web app. So we just added that rule. So it's in place. Let's also quickly check that if the rule is saved. So we see that the rule is saved. So we see the front door dot backend rule that we created. Now we are going to test it. So let me go to the web app, like directly accessing the web app, and I will also show that like how to access it using the front door hostname. So we will open it in a new browser. So I'm going to launch the web app. Let's see what happens. So we are getting a forbidden error that we cannot access the web app. So this is what we expect, right? We should not be able to access the web app directly, hitting the app service hostname, and we can only access it using the front door. So let me also try to open it from the front door. So I'm going to grab the front door hostname. I'm going to open it up in a browser. Let's see if we can see the web app.
Okay.
Yeah.
Yes.
So we can see the web app through the front door hostname. Yeah. So this is what we wanted to achieve. We wanted to block the access, direct access to the web app, and we want to access it only through the front door that we just saw. So
Nice.
I'm going to go ahead and remove the rule. And now Orestes will be presenting the next topic, which is the service endpoints. So over to you, Orestes.
Nice. Thanks a lot, Arthi, for the nice demo. So in the next walkthrough, we will perform a similar setup, but for application gateway, because now we saw that we allowed only front door to be able to reach our app service. So now with service endpoints, we're going to do the same thing, a similar setup, but this time we will only allow our application gateway to be able to reach the app service. A very common use case is to combine access restrictions that we saw in the previous demo with what we call service endpoints. So what is a service endpoint? A service endpoint is a feature that enables you to access, that enables you to secure Azure services, like for example, Azure Storage, Azure SQL Database, or in our case, Azure App Service, by allowing inbound traffic to flow directly to our app service from a specific subnet in your own Azure virtual network. This happens without going over the public internet. So with service endpoints, you can secure your Azure services by limiting access to them to only specific virtual networks, which reduces the surface area for potential attacks. This works for all virtual networks in the same region, and the typical setup using service endpoints is for an app service that is fronted by an application gateway that acts as a web application firewall device, like in this slide, for example. What this means that any inbound traffic now first needs to hit the application gateway before it's actually allowed to hit the app service. With service endpoints, you can also restrict access to your app service to more than one subnet in your Azure virtual network. So in this case, for example, we have a different subnet. So this VM here with the creation of this service endpoint from this subnet here, this VM in this case can also reach this app service here. Finally, with this setup, public traffic coming from the internet is no longer allowed to reach your app service. Now, in the next demo walkthrough, we will configure our app service to restrict access to only allow calls coming from our application gateway component. Arthi, would you like to show us?
Sure. Yeah. Let me start sharing. Right now, I rule that I created for the front door. So now I'm going to configure a similar way like we saw access restrictions for the front door. Like the same way, we create a rule that will only allow the application gateway to access the web app. So the direct access to the web app will now be blocked. Let's go ahead and create the rule for that. So I'm going to give the name as allow app gateway only. So since the action is allow, I choose allow, and the priority I choose to have a low priority value, so it gets higher precedence. And now here in the type, I'm going to choose virtual network here because we are going to use the application gateway. So since I have selected virtual network, I will see the drop down here for all the virtual networks. So I chose my virtual network, the app service networking demo that's in this resource group. And we see the subnet automatically gets selected, and that one is the app gateway subnet. So once I select the app gateway subnet here, automatically service endpoints will be enabled to this subnet, app gateway subnet, and it will only allow the app gateway subnet IP range to access the web application, which is the web app. So I have just added the rule I need to save so that it gets saved to the access restriction rule. Let me like once it's then we will see like the access restriction is on here. So let's try to do a refresh. Yeah, we see that the access restriction is on. We'll quickly go there and check if the rule that we created is in place. Yeah, I see the app gateway subnet here and the rule that we created. So let's go ahead and test it out. Right now, the first one I'm going to do is like I'm going to open the actual web app using the Azure websites.net, directly trying to access the web app. Let's see what happens. I see that I'm getting blocked. So it will not allow me to access the web app directly as I have configured like it should only allow me through the app gateway. So this worked. Let's go ahead and test the like through the application gateway public IP. Going back to the resource group in order to grab the public IP of the app gateway. And if we can access the inspector gadget web app from the public IP of the app gateway. Error that shows up here. We don't have to panic. It's like a very common error that happens whenever we configure some access restriction or whenever we add something that also relates to the app gateway. It will still work despite this 502 bad gateway error, but I will also show like in a future demo for the private link where we will actually be resolving this 502 bad gateway error. Uh, I am going to anyhow grab the public IP of the app gateway and try to open it up in the browser. So I just copied the public IP. I'm going to delete the rest of the stuffs and I'm going to open it up in the browser. I should be seeing the Inspector Gadget web app. Yeah, so I'm seeing the Inspector Gadget web app here and it's allowed only through the app gateway public IP. So I need to access it using the front door. So if you want, like I can, yeah,
So
I
this
can
means that,
quickly
for
show
example,
like if we can access it using the.
this means that, for example, now we are not also going to be able to access it through front door. So now we are only accessing through application gateway, right?
Exactly. Yeah. We should not be able to access the web app through the front door. So let me see, like I have grabbed the front door hostname and I'm opening up in a browser. I'm getting a 403 forbidden error. So we see that it is still blocking us if we try to access it from the front door. So let me zoom it out. Yeah. So we see that the forbidden error clearly shows that the web app access through the front door is also blocked. So it's only available using the app gateway's public IP for us now, as it's configured as a service endpoint. Over to you, Orestes. Yeah, we'll cover the next concept of private link.
Very nice. Thank you very much, Arthi. And let's continue with private link, and private endpoints. Service endpoints are one way to lock down incoming traffic, but they don't prevent access to the public IP for your app service. Normally, when you deploy an app service in Azure, it is accessible over the public internet through a public IP address. This means that anyone on the internet can potentially access your app service, which may not be ideal for certain scenarios where security is a concern. To address this, Azure provides a service called Private Endpoint, which allows you to securely access your app service over a private, isolated network connection without exposing it to the public internet. Now, private endpoints use Azure Private Link. This is Private Link here. To create a private IP address within your virtual network, which serves as the endpoint for your app service. With private endpoints, your app service is only accessible to authorized users and services that have been granted specific access to the private network connection. Now, using a private endpoints has several benefits. First, it improves the security of your app service by preventing direct access over the public internet, which can help protect against distributed denial of service attacks. Second, it allows you to access other Azure resources securely, such as, for example, a database or a storage account, without exposing them to the public internet. Now, it's worth noting here that you can create multiple private endpoints for the same app service and place them in different virtual networks in different regions. Like in this case, for example, we have a private endpoint created here in the West Europe VNet, here in the West Europe region. And we also created another private endpoint for the same app service, and we placed it inside this subnet of the North Europe VNet here in a different region. So in this case, both traffic coming from this VNet here and also from this VNet here is allowed to access the app service in this case. This can help to improve the availability and resilience of your app service, as well as provide additional security by giving traffic within your private network. Another key benefit of private endpoints is that they also allow you to connect to your app service from on-premises systems over site-to-site VPN or express route connections. This means you can securely access your app service from your corporate network without having to expose the app service to the public internet. Additionally, you can connect to your app service over virtual network peering and even global virtual network peering, allowing you to access your app service from other virtual networks in the same region or even in other regions around the world. Like in this case, we have a VNet in US, which is peered through a global peering with this VNet in North Europe, like we see here in this slide. So traffic from this machine here in this VNet in the US region is allowed to flow to this VNet in North Europe and actually reach the private endpoint and eventually reach the app service here. So like we already saw, by setting up private endpoints, you can create a private IP address for your app service within your virtual network. And this actually removes public access to your app service and actually blocks all public incoming calls. And your app service is only accessible to authorized users and services that have been granted specific access to the private network connection. One final thing to note is that once you create a private endpoint, additional DNS settings need to be made. For example, if I had something like myapp.azurewebsites.net, this now needs to point to myapp.privatelink.azurewebsites.net, which in its turn points to your private IP address. You can either use the DNS capabilities on the virtual network, which can create the necessary DNS records for you inside the private DNS zone, which we're also going to use in the demo walkthrough, or you can decide to run your own DNS server if you want. And now in this walkthrough, we're going to create a private endpoint for our app service. Arthi, back to you.
Sure. Thanks, Orestes, for the private link concepts. I'll start sharing my screen. So we are in the networking page, and I just removed the service endpoint access restriction rule that I previously created for app gateway access. And now we are going to see how to create a private endpoint. So this is the networking page and the place from where we can actually create a private endpoint. So I'm going to click on the private endpoint. So I'm going to click on add, and I choose to use express mode. Express mode makes it faster for us to configure the private endpoint and create one. So I'm going to give a name, app service PE. So this is the private endpoint name. So I'm selecting the right VNet here. Once I choose the VNet, it's asking for a dedicated subnet here, like that is for the app gateway as well. Like a dedicated subnet is needed for the app gateway deployment. For the private link, we need a dedicated subnet for the private link. So we choose to use PL subnet. And one thing to note here is that they integrate with private DNS zone. So this has to be set to yes. Unless we set it to yes, it will not be integrated with the private DNS zone. Like the private DNS zone will not be able to connect to the VNet. So in order for this to be possible, the private DNS zone to communicate with the VNet, we need to give this to S. This is something that we need to make sure as we create the private endpoint. And once we create the private endpoint, we will also see like additionally, we will have like some other resources as well that gets created, which will be the private DNS zone and also the private endpoints network interface card. We will see all that getting created as we try to create a private endpoint connection.
So you're placing this private endpoint right now, you're placing it inside the private link subnet, right? So this is a subnet that we created in this demo setup. This has a specific IP range. So eventually it will take a private IP address from this specific subnet. Our app service will take an IP address from there.
Exactly. You brought that point very clear and crisp there. It's basically the PL subnet and the address range from where this app service PE gets an IP from that range. We will also see like what is that IP. So let me go to the networking page to show that. If I do a refresh, it's going to show a change in the inbound address. And I'm hoping that I should no more see a public IP here. And I should see a private IP, which will be the inbound IP address. Let's see. It's getting
So
loaded.
in this case, it will have the private IP of the private link subnet, which is it belongs to this private link subnet, this inbound address
Yes,
here.
yes, yes.
So it's
Since
like that.
the private endpoint is created, we hope to see like the private endpoints turned on, and also the inbound address should show like a private IP for us. So let's try to open up the page again. I think it's having a glitch. So let me go back to the web app, or let me try to duplicate it. Okay, yeah. Now we have it.
Okay.
So the private endpoints is turned on, and we see like the inbound address now has an IP from the PL subnet's IP address range. We will also quickly confirm if the PL subnet has an IP range of 10.0.2.0/24. So for that, we will revisit the virtual network. So I'm going back to the virtual network that
Can
contains
you zoom
all
up?
the subnets.
Can you zoom
Yeah,
up a bit?
sure. Yeah. Let me try zooming it up. Yeah, so I have zoomed it up.
Okay, cool.
So yeah, so now we go back to the subnets page where we can see the subnets. We see that the PL subnet has a range of 10.0.2.0/24. So this private endpoint that we created in the subnet, it got an IP from this range 10.0.2.4. So we just saw that. And let me go back to the app service networking demo resource group, and I wanted to quickly show like if there are other resources that got created as we created the private endpoint. So yeah, we see that once the private endpoint is created, this is the private endpoint, and we see the network interface card that gets created. So this one, and we also see the private DNS zone that got created after we created the private endpoint. So I'm going into the private link .azure websites.net, the private DNS zone, and in this private DNS zone, like as we see, there is a record for the exact main site, and there is also a record for the SCM site that we see here that has the SCM here. So these two are pointing to the private endpoint 0.2.4. So the private DNS zone, we just confirmed that it has two records that connects to the private endpoint IP with a record. The ID network link confirms that the application of the private DNS zone is completed and the link status is completed and it's integrated with the virtual network, which is the app service networking demo. So we just had all the private link related things done, like we created the private endpoint. So now let me try to access the web app directly. If it allows me to access the web app directly over the public internet. So it should not let me access the web app directly, like a public access, because it's now a private endpoint. So if I try to open the web app, I'm getting blocked. So I'm no more able to access the web app directly using the Azure Websites.net hostname, like over the public internet. So it's like now blocked and is private. So let's see if there is a other way of accessing the web app. So for this, what I'm going to do is like I'm going to use the application gateway that also sits in the same VNet as the private endpoint. So I'm going to try to open it using the application gateway's public IP. So let me go back to the application gateway. I see. So previously also we saw the same error, the 502 bad gateway error. This generally happens whenever we configure something, and this is very common. We don't have to panic. But now what I'm going to do is like I'm going to resolve this error, and I'm going to show like how I'm going to resolve this error. So let me try to open up the Cloud Shell. So with this 502 bad gateway error, what I can do is like I can actually do like a restart on the app gateway, which is nothing but a start and stop operation. So if I do that, I should not be able to like I should not be able to see that 502 bad gateway error anymore. I should be only able to see the app gateway like in remote. It should be working. So I'm going to do a stop operation now. So let me paste the command to stop the app gateway.
I think it has a bullet on the front, Arthi, so you need to,
Yeah,
yes.
yeah, yeah. So I think, yeah, since it has a bullet, so that's something to note. Like we should have like with nothing before the AC. So since I copied, what I am passing here as parameter is like I'm going to stop the app gateway. So I use the easy network application gateway and the operation is stop. And that's why I mentioned stop. And the hyphen G is the parameter that uses to pass the resource group name. And the hyphen N is the parameter that passes the application gateway name there. So these are the things that needed that I need to have it handy in order to do the stop operation. It will take some time generally. That's why I see that it's running and I also see like it's updating the app gateway from here. So once this is done, I will do like a start operation. So I have a question like a very common question that we generally have customers ask us like what's the difference between private endpoint and service endpoint? Can you explain that to us, Orestes,
Yes,
as
of
this goes
course.
on?
And thanks a lot for the question, Arthi. That's a very common question we get. The big difference between private endpoints and service endpoints is that private endpoints also allow you to connect to your app service from on-prem systems over site-to-site VPN or express route connections, like we saw in the diagram earlier. Additionally, you can connect to your app service over virtual network peering and even global virtual network peering. We saw that in the diagram earlier. Also, private endpoints prevent data exfiltration because the only thing you can reach across the private endpoint is the application with which it's configured. Private endpoints grant network access to specific resources behind a given service, providing you with granular segmentation. Finally, what you need to know is that a service endpoint remains a publicly routable IP address, but on the other hand, the private endpoint is a private IP in the address space of the virtual network where the private endpoint is configured, actually. So these are the main differences between the two, and we saw them both today.
Yeah, this is like a very common question, and you explained it well. Like the service endpoint, it will still hold a public IP for the front end, so it will still be a public one. And the private endpoint, it lets us have a public IP. Like there is no more public IP that gets attached to the web app, so it can be private with a private IP from the subnet. So we just see that the stop operation is complete. So now we can try to run the other command that will start the app gateway. So all the change that I need to make here is like I change from stop to start. So I'm going to do like a start operation, which is also going to run, and we will see an updating here in the app gateway. And once this runs, like we will no more have the all the instances are having a bad gateway error or unhealthy. This error message goes off once we do a restart on the app gateway. So this is a quick measure that we take to resolve the 502 bad gateway error that generally happens when the backends are unhealthy. So I also have one another common question that we have like customers ask us. One another question is like, what's the main difference between front door and app gateway? Like when to choose front door and when to choose app gateway. Can you explain that for us, Orestes?
Yes, yes. Thanks a lot, Arthur, for bringing this to our attention here, because this is also another very good question we have from customers. So we saw both application gateway and front door till now, those two setups for locking down the inbound calls to our app service. So what's the difference between the two, and when do you choose the one over the other? So while both front door and application gateway are layer 7, which means HTTP or HTTPS load balancers, the primary difference is that a front door is a non-regional service that runs on our edge network or else POP locations, whereas application gateway is a regional service. Application gateway can be injected into a virtual network or else VNet, and has full connectivity to backend services, to our backend services. While on the other hand, front door can connect to private backends exposed via private endpoints, but it requires Azure Front Door Premium SKU, which is a little bit more expensive. Finally, Azure Front Door provides the same services as Application Gateway and some additional ones, like, for example, Content Delivery Network or LCDN, caching, and also dynamic site acceleration. So these are the main difference between the two, and the choice of which one of those will depend on your requirements, let's say.
Gotcha. So front door is a global service, and the application gateway is a regional service that we
Yes.
use for those scenarios. Yeah. And we need the premium SKU for using the front door private link service, right? In
Yeah,
order to
yes,
leverage.
for getting access to the private app service through a private endpoint, yes, we need the Azure Front Door Premium SKU for that.
Okay.
But in both cases, we use them as a front for our app service in order to use like web application firewall in front of our app service and be more secure. Our app service to be more secure in this case.
Gotcha. Yeah. So now, once the start operation finishes, yeah, we see the start operation just seemed like it finished, and we no more see the updating. Let's quickly check what's the operational state of the app gateway. Yeah, it shows like it's running, so we are good to go ahead and test. I'll grab the application gateway. I'll close this window. So I'll grab the public IP of the application gateway. and I'll try to open it up in a browser. We will also cover that explanation that will answer the question like how it works through the application gateway public IP for us now. It should basically we don't have that access restriction rule in place that will only allow the access restriction to give that access. So how it works to actually launch the web app using the public IP of the application gateway. So basically, what happens is the private link that we created, the private endpoint, it sits in the PL subnet, and the application gateway is deployed in the app gateway subnet. And both the subnets that resides in the same virtual network, which is the app service networking demo virtual network. So they are connected through the same virtual network, which is why the application gateway like it can still connect to the private endpoint, which is the web app. So we can see that we can launch the web app using the app gateway. That's why we are able to still achieve despite the web app is like a private endpoint, it's not accessible over the public internet. We still see that we can access it using the public IP of the application gateway. So
So there is no
we
special
just saw,
setup that we
yeah,
made. We just created a private endpoint, and because we placed that private endpoint inside the private link subnet, we are able to access it through the application gateway because it resides, the application gateway component inside, it resides inside the subnet, which is inside the same VNet as the private link subnet. So there's no special.
exactly.
Okay, cool.
Yeah, there is no specific configuration that we need to make just because it's the same virtual network that houses app gateway subnet and also the private link subnet. So they are connected. So we just saw that we can access it using the public IP of the application gateway. I will also show like how this happens through the public IP of the application gateway. We'll take a look into the backend setting here. So in the backend settings, like I see that I chose like override with specific domain name. And with this, I have overrided the host name as app service networking demo and the whole name of the web app dot azure websites dot net. So I have given this as the specific domain name here. But generally, this is not a very good practice to follow. We recommend customers to use their own custom domains and use that in the app service. Basically, they have to add that custom domain in the app service, and we recommend using that custom domain in the application gateway as well. So they will be entering that custom domain here as well with override with specific domain name. But in case they want to like use it from the app service, if they want to associate a custom domain from there, they can just use the pick host name from backend target. This option that will automatically grab the host name that's associated with the app service. So this is a general recommended practice, for customers to use pick host name from backend target, and also like add a custom domain on the app services. So this is why the application gateway public IP, it points to this host name. So this is basically this explains why we are able to access it with the public IP of the application gateway here. We just saw the private link concept from the app gateway perspective. Now we will also show like how to use it from the front door perspective, like how to create a private link on the front door and how to test it out. So I'll go back to the resource group. In order for that to be possible, as Orestes mentioned, the front door profile needs a premium SKU. So we'll
Mhm.
also see if we have that premium SKU here. We see
Yeah.
the front door premium here that says that we can use the private link service. So in order to use the private link service on the front door, I'm going to origin group where I can configure the origin, like I can enable the private link service from there. We will also see that. I see the origin here is the app service that was added. Now here, if I scroll down, I see that I can create like I can enable the private link service from here. So I see that there's a checkbox that I can check. So I enable the private link service. It will ask for a region. So I choose like East US as it's closest to the West US where it's actually deployed, the app service. But front door is a global resource. So I choose like sites. So sites means I'm using the web app or the sites as the target sub resource for the private link. So here I give like a message. This we will see quickly when we apply change to the origin and save it to the front door. Like we are going to update it to the front door through the origin group settings. So once this gets saved, we will see like if we navigate to the app services, like we will see there will be the private endpoint that gets created when we navigate to the networking page there. So I'm going to go back to the app service as it gets saved to the front door. We can like check from here if it is saved. So it's still updating. Let's wait. So I'm trying to open the networking page here for us where we can actually see the endpoints.
So we're essentially creating a separate private
So this,
endpoint for the same service, if I understood correctly here.
yes, this is a separate private endpoint that we are creating from the front door service. So this one, we will see also there is a difference, a very minute difference there from the private endpoint that we previously created ourselves from the networking page, like through the private endpoint and adding the private endpoint option. Through that, we created that got an IP from the IP range of the subnet. But here we hope to see like there will be a different private endpoint that gets created that will not be accessible to us. So let's see the difference there. I see like it's still going on updating the front door. So it updated. Hope to see the changes here. So if I go back to the private endpoints, there will be one more private endpoint there, but I need to approve that private endpoint. So let me quickly go to the private endpoint. That's why it's not showing up in the inbound address yet.
So you now you create a request for creating a new private endpoint for this sub-service. So probably you are going to need to go to the private endpoints blade here and just approve this private endpoint connection explicitly to give it access.
Exactly. Yeah. Yeah.
Okay.
It will be in a pending state. Yeah. This is the one that we created from the front door. So
Mhm.
as we enable the private link service, this automatically gets created by the front door. And this is created in the front door managed VNet that is only accessible to the Azure end, like that is managed by Azure. So it is not accessible to us. So if I try to open it in a browser, like if I click on this, I should not be able to access it. So that's what I get. I will not be able to access it because it gets created by the front door service. So it will not be accessible for us, but it is something that front door creates on our behalf. So I approve it so that we can use this private endpoint connection to connect as a private endpoint. Uh, and we can see like how this web app will now be used as a private endpoint from the front door. So we will see how to test it out. Let's try to do a refresh. it gets approved soon. So it's basically these are the states, like from pending it will show like approving, and once it's done we see like an approved state here. So once it's approved we are good to test. So let's see, we just see that it is approved now as we do a refresh. So let's go ahead and test it out. And before testing it out, I wanted to show like there will be another inbound address that gets added to this page as we just approved the new private endpoint connection that's created from the front door. Let's see what the difference is. So we don't
Private.
see that, yeah. So we don't see that the IP range is something similar to what we have in the virtual network address space. So this clearly shows that this is created by the front door, and this is a managed VNet by Azure. So this one is not accessible for us, and it got a different IP here. So this differentiates between the private endpoint that we created from the private link subnet, and the one that gets created from the front door and that got a new IP here. So these are the differences that I wanted to point out. So now let's go ahead and test if we can actually access the web app, which is going to be a private endpoint, but we should be able to access the web app through the front door host name. So let's see, like if we can access the front door host name and open it up in a browser, and we see the application there. So I go to the app service networking, the front door profile. So what I'm going to do here is like I'm going to grab the front door host name for us. So this is the front door host name. I just copied it. So now I'm going to open it up in the browser and see if we can have the web app, which is the private endpoint from the front. Yeah, I see the inspector gadget web app is getting loaded as we
Nice.
try to like open it up with the front door host name. So this is what we just did. Like basically, we are not able to access it directly over the public internet, and only through the front door host name we try to access it, and it is going to be a private endpoint. So while we proved that it's only accessible through the front door host name, we also wanted to check like if we can directly access the web app, which is also one another question that we have. So let's
I think
quickly
Arti,
test it out.
Arti,
I'll
I
try.
think we can leave it for now because we have only 3 minutes left. So we can go to recap
Okay.
this session today. Thank you very much.
Sure. Yeah. Go ahead,
So
Ristis. You're good.
thanks a lot, Arti, for great demos. So to sum up, let's briefly mention the 3 scenarios we saw today. First of all, we have the application gateway plus access restrictions plus service endpoint, this setup uses an Azure application gateway as the entry point to your app service. It also incorporates access restrictions and service endpoints to control the incoming traffic. Access restrictions, as we said, allow you to block traffic from specific IP addresses or ranges, while service endpoints allow you to create an isolated network connection between your app gateway and app gateway subnet and your app service, in this case. So the request goes to this public IP and then flows through the app gateway, and with the user of the service endpoint is able to access the app service. The second setup is Azure Front Door plus access restrictions plus the HTTP header control with the use of the Azure FDID header. This setup uses Azure Front Door as the entry point to your app service, and it also incorporates access restrictions to control incoming traffic as well as HTTP header control with the use of the Azure FDID header. As we said, the Azure FDID header can be used to validate that requests to your app service are originating only from your own Azure Front Door instance, adding an extra layer of security. Without that, and only by using the Azure front door.backend service tag as an access restriction rule would mean that all front door instances by all customers would be able to reach your app service. So in this case, the request flows through the front door and reaches the app service. And also the request comes from the public internet and blocked here. Finally, we saw private endpoints. So first setup would be a private endpoint. We use the app service private endpoint to create a private isolated network connection for our app service. This ensures that incoming traffic is only allowed through the private network connection and not through the public internet. In this case, in the first case, the application gateway component is able to reach the app service because it resides inside the same VNet as the private endpoint of the app service. And finally, we have the front door setup, which uses Azure Front Door Premium as the entry point to your app service. It also incorporates app service private endpoint to create a private isolated network connection between your app service and Azure Front Door Premium. And this ensures that incoming traffic is only allowed through the private network connection and not through the public internet. So once again, you can go to the link shown in this slide, which is a collection that contains all learning content for properly understanding app service networking. And it also contains all the demo samples that we showed today throughout this session. And also, don't miss part 2 in 2 days from now, where you will continue your learning with the next episode in the App Service Networking series. And you will learn about ways to lock down outbound calls from your app service, and also see about what single tenancy is through the use of an app service environment. Thank you very much, everyone, for your time today. Have a great rest of the day. Goodbye.
Thank you. Thanks, Orestes. Thanks, everyone.